to be in town and who said she said she'd come and talk about like all the poor economics related stuff in its relation to product design. The thing is, she can only come on October 8th, which is the day of your strategy presentations. So what I would propose is we do the strategy presentations the next day, which would be, let's see, it would be after Columbus Day. It would be Wednesday the 15th. Which is kind of late because your concept presentations are the 27th. So what do you guys think? It does. You're going to have to be ready, I think, for your strategy presentation still on the 8th. But I think this is a good person to come in and we'll have a really good discussion. She's involved with the Development Impact Lab at Berkeley, which is run through the economics department, but also interacts a lot with engineering. So she brings a really good perspective. She's also helping launch a new journal through Elsevier called Development Engineering. But they want kind of economics and engineering all happening at the same time. So anybody have a big problem with that? Can we do it? I think so. I think it's a worthwhile like switcheroo. So okay, I'll tell her yes, that we're on for that. But I just want to check with you guys first in case there was any glaring objections. Okay, so today I want to talk about products. You can't really see that, can you? Products that have reached really, really high levels of dissemination and scale. Actually, can you close the blinds, Sarah? You just pull that cord on the right. That's what's blocking the light. Because I do want to keep these lights on. You're going to get graded on this. No, you just pull it to the side and let it down. Yeah. You're getting there. Sometimes you have to pull up a little bit. All right.
If I put down, you meant break, right?
We're getting there. Nice. All right. This is the only dark picture, but so I put this picture up here. You know, I use this picture as the intro slide. Anybody know what this is? Oh yeah, it's cars, but what car? It's a Model T, yeah. And what I think is cool about this is like America at that time was a bit like a emerging market. It was an emerging market, industrial revolution and people starting to buy these big devices. And so there's a lot of innovations in manufacturing that enabled Henry Ford to make a really pretty high quality product at massive volumes cost effectively. So I think this is a great picture and pretty apropos to today's lecture. So anyway, I'll start out with showing this bar graph, which is on a log scale, right? And all of these are multi-part products that have been sold at massive scales in emerging markets, right? And we're going to talk about these today and kind of why they've been so successful. So this first one's our benchmark. And anybody guess what it is? It's at 4 billion, and I'll just put a caveat there, 4 billion since about 1950, but it's older than that. Yeah?
McDonald's cheeseburger?
No. This is a product. Like actually, no, this is, like, note we have like motorcycles here and hardware and stuff. These are like, okay. Are you, yeah, is that, you're from MECE, aren't you? Come on. That's like a Sloan School answer. All right. AK-47. No, that's a good guess, but it's at 4 billion. Yeah, remember it's a log scale, so that's a billion. It's at 4 billion. Anybody else guess? Like, what's a product that you see everywhere? Big, it's a pretty big mechanical, yeah, exactly, bicycles, right? And this is called the safety bicycle. Right? And it started getting popularized in the late 1800s. Oh shoot, I didn't bring the books. So there's a great book by a guy named Archibald Sharp that's called like Bicycles and Tricycles, blah, blah, blah. It was written in 1897. And it talks all about the state of the art of bike technology. It's really, really cool. But like not much has changed. So anyway, this was a safety bicycle. It started getting popular in the 1880s. And to contrast it, this is what else was on the market beforehand? The penny farthing, right? Death trap, right? Total death trap. Why is this such a death trap? Think about this from an engineering perspective. Why was this such a good design?
When you stop,
Yeah. Yeah, you can put your foot down when you stop. Yeah, all sorts of good user-centered factors. But not just that, what else? Lower CG, one, but also CG set back from the front wheel much farther, right? Because when you hit an obstacle on this, that deceleration is going to try to tip you this way, and your only counteracting moment is your weight acting down there. So it works out, this length versus that length is really important. So a safety bike sets your center of gravity back and also sets it down, so it's a lot safer, right? Pretty well named. Okay, so yeah, the restoring moment's much better on a safety bicycle. So right now, I looked this up, there's about 100 million bikes manufactured per year. Most are in China, about 80% in China, there's 12% in the EU. And there's about 4 billion bicycles that have been produced since 1950. I don't know about going back further than that, I wasn't able to find it. But the reason I put up these pictures is it blows my mind how similar this and this and this are. Like, it hasn't changed. Like, I don't know, does that blow your mind too? Like, think of like aircraft, right, from 1901, or 1904, when the Wright brothers flew. Massive changes, but it's basically the exact same layout, same interface between the person and the machine. So it's this really, really like efficient, fast machine. You can do a lot of things with it. Like, has anybody seen this type of picture in developing countries? You see it all the time. People hauling stuff. But it's just such an amazing invention. I have huge respect for bicycles. So it's affordable, fast. It's a lot more affordable than a car or a motorcycle, and it's been produced at massive economies scale. And when we were doing the development of the LFC, this is a seat frame from one of our wheelchairs. The parts, like, people ask us all the time, hey, why can't you use used bike parts? And the issue is that, one, it's hard to get a reliable supply of all the same parts, but two, you could buy these parts for almost the raw material cost. They're produced at such massive economies of scale, which is pretty cool. And these parts are the same as what was used 100 years ago, which is also very cool. But anyway, the focus of the lecture is not on bikes. It's just our benchmark today. What do you think the next bar is here? This is at 250 million. This is a product I think all of you probably own.
cell phone?
Yeah, exactly. But not just any cell phone, this cell phone. Yes. Well, not just the brick. You guys know the name of this? Yeah, Nokia 1100. Nice. So I have 3 here. One is you can just undo the tape and take it apart. And the others you can actually play with. They're on. So, you guys have been reading about a lot of this ethnographic stuff and also related to this cell phone. What do you think are some important design features here? What made this successful? The point of this lecture today is to think about, like, what made these products so crazy successful? Snake. That's it. Yeah. It's ruined economies because everybody's just sitting at home playing Snake. Totally unproductive. No, what do you think?
Simplicity.
Simplicity. What in particular?
Easy to use, like maneuver around, get things done. We call syntax.
Yeah, pretty easy to navigate the user interface. What else? I'm sorry I don't have 30 of these to pass out. Yeah.
Pretty mechanically robust. Like, all the moving parts are sealed against water.
Ah, do you know specifically? Like, do you have one? Pass one to him. Yeah. Look at it specifically. What do you think? What is robust about that? There's a big clear. Yeah, that's a piece of stamped sheet metal. No, it's not actually that. Yeah?
It doesn't bend like an iPhone.
It doesn't. It has a higher moment of inertia than a. No, it's one of the big ones, is the keypad. So if you could pop the keypad out. You can also break the screen. Yeah, if you pop the keypad out, here's the keypad. It's one piece, right? And they designed this so dust can't get inside. Pretty cool. What other features do you think are important to this?
Flashlight.
Yeah. Yeah, this was like one of the first phones that has a flashlight, which is pretty useful if you're, don't have electricity around you. Any other features that could you guess might be important for the demographics that this was designed for? Cheap. Yeah, it was a lot cheaper than other phones at the time. It was about $20. Yeah.
Like the charging method, does that have like a removable battery or something?
That's close. It does have a removable battery, but a lot of other phones did. But it relates to charging. What do you think?
A long-lasting battery.
Yeah. Yeah. Do you know how long? The standby time?
2 days, something 4 days.
2 weeks. Yeah, over 2 weeks. Yeah, amazing, right? So if you're in an area where you can't get grid access to charge this, except every 2 weeks, then you're okay. That's standby time. That's not talk time. Yeah. Yeah, so, and there's some other things too we'll talk about. So flashlight was a big thing, definitely. As we said, there's 250 million of these sold. And that's just this model. It's not just cell phones in general. I think the iPhone has since passed this, actually. Does anybody know? But this is the phone that really, really cracked open emerging markets. And I wish Jan Chipchase wrote about this more in his book, because he was really part of the team that did all the ethnographic work to figure out what people wanted in this phone. But the lesson there is they went to the emerging markets where they thought this thing would sell. It floats, which is a nice feature. This is called the fisherman's phone sometimes, because you can drop it in water, turn it off, bring it back, dry it out, and it'll work again. And it floats, so you don't lose it, which is pretty cool. Has nice grip, and feel, and it doesn't slip out of your hands. We talked about the keypad, reducing dust getting inside. And it has, you mentioned the easy-to-use features, that are critical to a person. What's cool, too, is you can transfer money with these. You've read about M-Pesa, right, in Kenya. Yeah, because it text messages. And it has Snake, as Jeff mentioned. Yeah, so talk time up to 4 hours and standby time up to 400 hours. That's crazy. Cheap cost, as you mentioned. And this is a really interesting point. And I want to, we'll get into this with some of the other products. You'll sometimes find that there's an event outside of your control that can really help catalyze the creation of a new product and the success of a new product. So not only did Nokia do a fantastic job designing this, but right around the time it was launched, Reliance, which is the biggest telecommunications provider in India, announced a big discount in the price point of making calls. So they kind of prepped the market for larger scale adoption of phones because they made them more affordable to use, right? And Nokia came in to make them more affordable to buy. And I don't know if Nokia intentionally read that market change to know the market was ripe for a new product, but it definitely helped the distribution of this phone. All right, cool. So next product, 175 million. Any guesses? Bic pens, it's a little, so this isn't I didn't survey every product ever made. I'm sure there's more Bic pens made per year than 75 million. No, but this is another you'll notice all these products are multi-component, pretty complicated, mechanical systems, right? What?
Pumps.
What type of pump? You're wrong, but yeah. Not pumps. No, specific product. You've seen it tons and tons of times on TV. What's that?
What's a filter?
A water filter? No, we're going to get to that in the end. No, not even close to that scale. Yeah.
Yeah, Kalashnikov?
Yes. The AK-47. Kalashnikov. And I want to be very sensitive about this. I'm not trying to praise the killing power of this machine, right? This is a horrible, destructive weapon for society. But it is a mechanical device that has somehow reached huge scales of distribution. And then I think there's a lot we can learn from it. And actually, there's so much we can learn from it. The next lecture is a guest lecture about this. And I'm hoping we'll actually have some, or one, here. Now, I'm not kidding. Yeah, the chief of police does it. I'm not going to waltz in with it. These are crazy. If they're fully automatic, they're crazy, crazy illegal. Okay, so why do you think this product has been so successful, so largely disseminated? What do you think? Yeah, Johnny.
People in just about any environment.
What do you mean by that?
So they've like taken these things, they've thrown them in mud. They use a guy that even stuffed cookies in them.
Yep.
And they're still fired.
Yep, really, really robust. Do you have a sense of mechanically how they could do that?
I think
Very
it was
simple action.
Yep, that's one of them. What's-
finding in they give more clearance or something.
Yeah, there's pretty loose tolerances in them. Yep, that's another thing. What else? What else do you think? Yeah.
Isn't it also a function that the Soviets made millions of them? And
Yes.
then just spread them out?
Gave them to everybody, made them everywhere. Yep, that was a big part of it. Yep, they helped proliferate them. What else? What do you think makes this so usable? Yeah?
Well, just it's super simple user-friendly.
Yeah.
It's a huge magazine. It's very obvious just by looking at how it works.
Yep.
So anyone across languages can figure out how it works.
And I put this picture here because, like, literally a kid can learn how to use it in like 10 minutes. Yeah. Yeah?
Similar to that, it's probably easy to service.
Yeah. You can rip it down. What about the manufacturing of it? Not only that, but how do you think they manufacture it so cheaply?
Probably like stamped parts, wooden components.
Yeah, it's made out of stamped sheet metal. You know, and they did that to minimize the machining. The old ones, and John will talk about this next class, the original ones were machined. They're like really beautifully machined. But, and they weren't able to hold tight enough tolerances with stamping when they first started making these. But now they're all made out of stamped sheet metal. Yeah, okay, so to run through this, there's been 175 million since 1948. The sheet metal makes it really cheap, lets you keep low tolerances. Johnny, as you said, really rugged and reliable. You could teach a child to use it in 10 minutes. They're pretty low weight, or the ammo they use is like assault rifle ammunition, and John will talk about this too. It's kind of midway between like a handgun bullet, which is more like heavy and short range, and a long range rifle. So you can carry a lot of ammunition pretty light. They're high velocity, small bullets, so you can shoot more times. It was given away to many countries by the Soviet Union, and it was manufactured everywhere. You know, here's a list of countries that have made it. So, huge, huge distribution. Okay, so the next product, what do you think? This one's at 60 million.
Disposable cameras?
No, I bet that's a good guess. I bet that's more. You know, if you look back through the 90s and stuff before digital cameras became common. No, this is a big product. It's like big in size. It's not a motorcycles, yes. In fact, the Honda Super Cub. Yes. So some of you have been riding this, right? Yeah, good. Now, think about why this was such an amazingly successful product. And maybe, I think, if we have any volunteers, I think coming up here and actually sitting on it, you can get a better sense. So, anybody want to volunteer? Like, just talk, yeah, go ahead, Sarah. So you just talk through, like, you know, what it's like, how do you control it? So how do you control it?
How do you control it? I mean, it's got a pivot point that's optimal, so it's really easy to put back and forth.
Well, yeah, it's got a pretty low center of gravity. But what about like how do you shift it? How do you accelerate?
You shift with your feet.
That's actually the rear brake on your right foot. You haven't ridden it yet.
Left foot.
Left foot.
Obstacle.
Yep. There you go.
Okay.
Yeah, the kickstand's still down.
It turns on.
No, you shouldn't. Don't do that. You shouldn't turn it on in here. Yeah. No, but okay. So just to start out, you're a really no. You can stay there. Just think about her gender, right? And how you would sit on it compared to a regular motorcycle. Like when your feet are up on the pegs, right? How is that different maybe than a regular motorcycle?
We're not straddling.
You're not straddling it. Yeah, exactly. Right? So it makes this more acceptable culturally in different contexts. Right? That was a big part. So women can ride this. Right? Okay, there's another thing about how it's controlled that's really, really important. Yeah, exactly. Where's the clutch on a motorcycle? Yeah, it's right there. So what do you do with this hand? Exactly. Yeah. And that was one of the biggest innovations of this thing, right? You don't need your left hand at all, so you can use it for other tasks. And actually, this came out of the noodle delivery business, or was motivated by the noodle delivery business in Japan, so the noodle drivers could hold your noodles in one hand and drive the thing with the other. What else? What else is clever about how this thing would perform? This is such a brilliant product. Like,
They're really narrow. I mean, they're not
yeah.
big tires.
Yep, they're very narrow, but what else about the wheels? Compare it to a Vespa. You guys know that, the little Italian scooter? How's this different than a Vespa? Yeah, much bigger wheels, like way bigger wheels. This has, I think, 17-inch wheels, and the original Vespas had 8-inch wheels. Why does that matter?
Rough roads, going to take a bigger bump.
Exactly. Much smoother ride on rough roads. Yep. This product is so brilliant, like we bought one. How crazy, we bought this for only this class, like this lecture right here. But I think it's like, I know, it's crazy, and it's fun for you guys to ride. But yeah, I think it's just such a brilliant product. Okay, so what else about it you think contributed to its mass distribution? Yeah.
It's got utility racks where you can load
Yep.
stuff on it. That just good place.
Yep. You put stuff on the back. What else? Yep. Oh yeah, that's good. Yep. It's got mud guards. It's got rear passenger pegs right there, so you can bring a passenger. What else?
In a lot of places, you don't need a motorcycle license to ride it.
Yeah, because the original ones were 50 cc. This one's 70. So I think here in Mass you would have to get a license, but a lot of places under 50 you don't need it. What else? Yeah.
It's got a slow start.
Yep. But it also has a kickstart, which is cool. If your battery dies, the kickstart's on the other side, so you can't see it. What about the manufacturing? Can you see any clues here?
American pieces. Doesn't seem like.
Yeah, how does the frame compare to like how you typically envision a motorcycle?
Can you go that way also? So you can
It's much more bicycle.
see what- There you go.
It's somewhat bicycle-like, but there's a key thing that somebody hasn't said yet. Why this was made so cheaply. Yeah, it's stamped. It's completely stamped. All these are stamped steel, right? Like literally every piece. And so that, that's a lot faster to assemble than like a welded steel frame with different components you have to weld together. You're okay. You can, put it down like that. Yeah, it won't tip. But what else? There's another big component. This one.
It's a plastic bag.
It's plastic. This is injection molded. This is a huge piece. Protects your legs from mud. It really helps form the shape of the bike, and it's one piece of injection molded plastic. This thing blows my mind. I love this product. It's amazing. So yeah, talk about a little more in detail. And there's more too. This is Michael.
I was going to comment that the bike in front of you is 32 years old and still runs no problem, very minimal problems.
Very minimal problems. Yes. Yeah, we have to, right now I think the idle jet in the carburetor is blocked. So you have to run it choked, but it still runs. But we should fix that because it's running a little rich. It does still run though. Okay, so there's 60 million of these. They're still made actually, but there's 60 million made in history. And they really designed this to be a global product. They certainly sold it in many, many different countries. When they designed this engine, it was a 50 cc engine in the original one, and comparatively it was a lot more powerful than other 50 cc engines on the market. It was 4.5 horsepower compared to about a 1 horsepower engine for similar size. So you got literally a lot more bang for your buck. We talked about the wheel size, much better going over bumps. We talked about the frame and the fairing, and ridden with one hand. And then, so in 1961, it was sold for $250, and that's about $2,000 in today's dollars, which is a pretty good price for a motorcycle. And you know, they were producing at massive scales by the 60s. They again, like the Kalashnikov, made it everywhere. You know, these are all the countries where they made these things. So, but and has anybody been to Vietnam? Yeah, you see these like swarms of motorcycles, and lots of them are these because they're affordable. But the next thing, this is my favorite part of this whole bike. So Honda did this ad campaign. I don't know if you can read it, but this is so subtle and so brilliant. They wrote, "You meet the nicest people on a Honda." Right? And so look at this guy, the preppy college kid, his nice girlfriend with their school books. You know, this is just like this wonderful image of what they want to portray as one of their customers, right? So remember, think back in the 1960s. What were motorcycles like in the 1960s? Does anybody know? They're Harleys. Yeah. And the people associated with motorcycles were like this. This is from Marlon Brando in The Wild One. He's actually riding a Triumph, but similar type thing. Motorcycles were associated with like ruffians, you know, the guys you didn't want your daughter to date. The motorcycles of that era were really finicky. They required a lot of maintenance. You had to rebuild the engine every few thousand miles, and your layperson wouldn't deal with that. It was too much of a pain. So they made the Honda both like really easy to use because it doesn't break, it's reliable, it doesn't need much service, but they totally changed the whole cultural context of the motorcycle, right? And that was a big part why it sold in such huge numbers. Yeah?
I know most of the motorcycles then were air-cooled. Is this one water-cooled?
No, this is also air-cooled. Yeah, it's that's a good question. If you look under, yeah, the head and the valve cover is finned underneath, but no, it's not water-cooled. Yeah, but isn't this awesome? Like, again, totally tweaking like a socioeconomic thing to make a successful product. I love that. Okay, so the next one is at 40 million. What do you think it is? It's another vehicle. I'll give you a hint. Yeah. No, you would think it is. It's not actually. Yes, it's Toyota Corolla. Good call. So here are some pictures of the Corolla through history. You know, this is one of the original ones. This is a brand new one. This is kind of a mid-era one. So what do you think made this thing successful?
Cheap and reliable.
Yeah, cheap and reliable. That was a big thing. Yeah. And that was, I would say, the biggest thing. And I think the other things aren't going to really stand out until we walk through the points. So to give you a little background about this, there's been 40 million made since the 60s. It's the most produced car in history. But this, again, has this really cool like socioeconomic history behind it that catalyzed its success. So Japan, remember Japan was decimated after World War II, right? And in 1964, they held the Olympic Games there. What happens when you hold an Olympic Games? Like, what does a city and a country have to do? Build infrastructure, right? So Japan had all these roads and all this nice infrastructure for the Olympics, and it made it really conducive for now people owning their own cars and driving them around. So the whole environment was kind of prepped for this vehicle. So right now in Japan, they make 600,000 Corollas a year, but they also make them everywhere. Again, that's another lesson here. They're cheap, but this is another cool socioeconomic thing. So in 1973, there was a big oil crisis worldwide, right? What was it, OPEC, the Middle Eastern countries like cut off the oil. So here's your 1960s, 70s Corolla. What did cars look like in America in those days? Muscle cars, right? Like big muscle cars. So, you know, you have this thing that gets like 2 miles per gallon, and then you got this guy that gets like 30 plus. You know, that oil crisis really, it also helped catalyze the sales of this. And that was the time when Toyota and Honda really got a foothold in the American market. And it was helped by that external effect. And so I don't really know how to characterize these external effects that can help us as engineers. But what I would say is like, look out for them. see what's happening. So like one great example right now is drone legislation, right? So like I think unmanned aerial vehicles could be like the next internet, right? It's a limited adopted technology right now. It's only adopted by hobbyists in the military, right? It sounds just like cell phones, just like the internet 20 years ago, right? So think about like when laws change, what you could use drones for. There's all sorts of stuff, not just like delivering Netflix movies, but like, heavy lifting and people transport and who knows, but legislation is holding it up right now in the US. That may change very soon and it could blow open huge new markets. So that's pretty cool. Okay, so we've talked about our really high volume of scale technologies. And these, I don't think any of these are what we would consider a developing world technology, right? Like what type of technologies do you usually associate with development? Yeah, water filters, like what else? Irrigation, pumps, yeah, lighting, right? So I wanted to make a contrast here between these guys, which sold in developing countries at massive scales. That's really where they made their money, versus developing world technologies that you consider, your kind of stereotypical developing world technologies. So let's talk about those for a second. The first one is solar lamps. And this was from a year ago, but the D-Lite, which is the most successful solar lamp right now, has sold 4.5 million. Yeah?
It seems like when you design for a developing country, it's more like the company is holding itself more around the customer than ever. Whereas, for instance, with the iPhone, it's like Steve Jobs will tell you what you want. It's more like a luxury. Whereas the developing world, it's like, for instance, with Nokia, for instance, like they're designing it so that people can use it. Like the Cushman phone, for instance, is very durable, it's lightweight, it lasts for a long time.
I would modify that a little bit, but you're hitting on, I think, what's a really important point. I think a lot of times development technology is designed because we think people are in a rough situation and we're trying to create this product that alleviates that rough situation. So clean water or water purifier to make clean water for health, right? I don't know, a clean cook stove so you don't get smoke inhalation. What's different about these products over here is, with maybe the exception of the Kalashnikov because it was given away, but the rest of them, people bought them because they want them, because they're awesome, right? They enable you to do a ton of stuff. So I don't know if you were touching on that, Johnny, but I think that's a difference sometimes in development technology where we design technologies to help people. But you have to also think about, like, people buy products because they want them. Yeah?
These products, it also seems like maybe they weren't initially targeted at like the developing world. They were targeted like more at the developed world, and then they spread because their characteristics made them perfect for the developing world. But they were initially sort of set towards a different market.
That's a good point. Well, the Super Cub wasn't. Japan in the 1960s would have been an emerging market. They're kind of coming out of the Marshall Plan. Same with the Corolla. And the Nokia was certainly for emerging markets. And there's features of that have now proliferated into higher level phones. Like most of our phones have a flashlight now. And I would guess it's from that. This was kind of the first phone with a flashlight. But that, I think that you guys need to, as designers, need to think about, like, why are you designing a product? Are you designing it because people need it? Or do you design it because they want it? Or are you doing both? The quip I like to make about our water purification work is that, like, unless you're dead, you've always had clean enough water in your life, right? And if it's clean enough, you may not even perceive it as horrible, right? And you've probably gotten it for free. So we have to think about, if we're designing water purification systems, we have to think about what is our value proposition to that consumer? Why would they now pay for this commodity that they've always gotten for free, right? So we have to, the way we're trying to add value is take the salt out, make it taste better, right? So yeah, let's talk about the developing world products. I think lighting certainly has a big return for people because now they can stay up, they can do other things. And this is growing pretty quickly, but it's still not at the level of these products that I showed before. The next one is treadle-powered pumps. IDE is kind of one of the big players here. They've done 1.4 million in their history. We're going to do a case study on these where you guys are going to use these pumps and actually see what it's like. But you're going to find that there's big limitations on how big a farm you could actually irrigate with these things. The next one is cook stoves. And I brought a couple of these. And there's been, I bet EnviroFit's closer to 1 million now. But I brought 2 of these. Here's one. It's called the Darfur stove. You guys are going to use these too in a few weeks. Here's the EnviroFit. But these are basically trying to serve the same type of consumer, right? Oops, sorry. Take this out. All right. So I think just look at them at a high level, right? And you could pass these around, but how is this one made? You have a sense? You see it? Yeah, it's stamped and then it looks like it's actually welded. I thought it was drawn, but that would be quite a deep draw. But you can see there's weld lines here. Yep, so it's made out of sheet metal. And then what else? What about this?
The plastic.
Nope, feel it.
It's cast.
Yeah, it's cast. Yep, so we got sheet metal and casting, and then you can't see it, but it actually has ceramic insulation on the side. And then how about the other one? How's that thing made? It's all sheet metal and riveted. So where do you think they make these?
Low labor cost countries.
Yeah, but these are 2 hugely different products. Or they do the same thing, but they're made really different ways.
Probably more labor content though.
That was made specifically for Darfur in Sudan, right? And they wanted to make it where they were using it. So why do you think they may have made it that way?
It's cheap to assemble, rivet.
Yeah, but more than that.
Yeah.
You got cheap labor, you got people in like camps hanging around. But even more than that, what are the tools required to make that versus this? Yeah, you need a